sequence.
We'll be looking at series now. So, an infinite series, or you want to say infinite. An infinite series is the limit of a sequence An infinite series is the limit of a sequence. So take note of that. So if the set A sub k is a sequence if this is a sequence, then the sum of the nth term of the nth partial sum of the nth partial sum S sub n of the sequence is defined as S sub n equals A1 plus A2 plus A3 plus and so on
And
up to AN.
predicting
And
that.
in simple term, you just say that's the summation A sub k, k running from 1 to n. A sub k, k running from 1 to n. So the partial sum is determined from the first n terms of the sequence AK. The partial sum is determined by the first n terms. Now, you remember when we started sequence, I gave the preliminary of sequence in O level, that arithmetic progression has its n term to be this, geometric progression has its n term to be this. Then I remember I told you that we also have other sequences.
Infinite sequence and
that we are going to meet later. Do you understand that now?
Yes, sir.
one of the popular sequence that I'm going to discuss or series is harmonic series. So when you say a series is harmonic, you will get to know this in the course of this series that we are talking about. Is that clear?
Yes.
Okay.
You think so?
For instance, let's say example. Can I scroll up?
Yes, you can.
Okay. So for instance now, if set K is a sequence, if this is a sequence, what is the partial sum? What is the partial sum S6? Are you there?
Yes, I'm there, sir.
Okay. So solution. So the first thing you will do is to get the sum to nth term. So if K is a sequence, now don't forget that in a sequence, I've told you that the number of terms, n, we start from 1, 2, 3, and so on. So in other words, the number of terms takes integer values, positive integers. So in this case now, the sum will now be 1, that is when it is 1, when K is 1, plus when it is 2, plus when it is 3, plus when it is 4, and that trend will continue until you get to the nth term. So
6.
I can equivalently say this is summation K with K running from 1 to n.
Okay.
So like this generalizes that now. So when n is now 6, that's S6. So you now have the sum to be summation K running from 1 to 6. Does that make sense now?
Yes, it does.
So which I can now say 1 plus 2 plus 3 plus 4 plus 5 plus 6. Then I stop. So that's a partial sum S6. Is that clear?
Yes, sir.
Okay.
I'll just copy that.
Can I scroll?
So just 1 minute. Okay.
Okay.
I'm there.
Let's see another one that will be technical. Number 2. Question says, consider the recursive sequence A1 equals to 1 and A sub n plus 1 equals 1 plus 1 over A sub n. Find the partial sum S5. Is that clear?
Yes.
So write that question so that you can concentrate on the solution properly.
Okay, sir. I'm there.
Okay. So from the question, we have been given that A1 is 1. And we now have AN plus 1 to be equal to 1 plus 1 over AN. So we'll now take it one after the other. When n is 1, so we're going to have A sub n plus 1 to become A2 equals 1 plus 1 over A1. Do you agree with that?
Yeah.
And A1 is 1. So we have 1 plus 1 over 1.
Yeah. True.
And you now say it's true, Abi?
Yes.
No, leave it like that. Don't say it's true.
Okay.
If you say it is true, you are right, but you won't be able to get the desired result that we are looking forward to.
Okay.
So leave it like that. Don't forget, the question says a recursive sequence. So you now consider when n is 2 now. Substitute 2 for n here. So we now have
A3
equals 1 over, equals 1 plus
plus
over
1 over A2.
A2.
Okay.
Am I communicating?
Yes, sir.
Okay. So that will now give us what?
That's 1 plus 1 over 2.
1 plus 1 over 2. Very good. 1 plus 1 over 2. Very good. So we also leave that one like that. You won't say it's 3 over 2.
Okay.
When n equals 3, you now have A4 equals 1 plus 1 over A3.
A3.
And that is going to be 1 plus 1 over our A3 is, if you add this together, that will give us what? 3 over 2.
Yeah.
So 1 over 3 over 2, which will now become 1 plus 2 over 3.
Okay. Yeah.
Does that make sense?
Yes, sir. It does.
Okay. When n equals 4, A5 will now be equal to 1 plus 1 over A4, which is going to be 1 plus 1 over. Now, if you add this together, that will give us 5 over 3.
We,
Do you agree with that?
yes, 5 over 3. Yes, sir.
Which will now become 1 plus 3
3 over 5.
over 5. That's A5. Remember, let me scroll up so that you see something up. That here, he said the partial sum is going to be A1 plus A2 plus A3 plus, and so on. Is that not it?
Yes, sir.
So that means I can now say the partial sum S5 now. S5 equals A1 plus A2 plus A3 plus A4 plus A5. Now, A1 has been given to be 1 plus A2. What is the A2 that we obtain? 1 plus 1 over 1.
1 over 1. Okay.
Plus A3. What do you get for
okay,
A3?
1
1
plus
plus
1 over
1
2.
over 2 plus A4.
Plus
1
1
plus
plus 2 over 3.
2 over 3 plus A5.
A5. 1 plus 3 over
3 over
5.
5. Is that clear?
Yes, sir.
Now, I can say that 1 over 1 is 1.
Yeah.
So I will now have 1 plus 2
2.
plus 1. I'm here now.
Okay, sir.
Plus 1 over 2. Because everything is addition, so I'm trying to remove the brackets.
Yeah.
But I'm not going to sum them up like that. So
okay.
We need to be very careful. So the next one is going to be 1 plus 2 over 3. Then plus 1 plus 3 over 5. Now, add all the whole number.
Okay. 6.
So if you add up all the whole numbers, you now have 6 plus the fractions now. 1 over 2 plus 2 over 3 plus 3 over 5. That's the partial sum, S5. Is that clear?
Yes, sir.
Write that.
Okay.
Now you can see that if you have simplified those fractions, the addition, the A2, the A3, if you have simplified them from the beginning, that is, if you turn A2 to 2, turn A3 to 3 over 2, there will be problem now getting this, because we are working towards deriving a particular formula.
Okay.
Where I draw, let me know.
Okay. So I don't even know how I said 2 for A3 equals 1 plus 1 over A2 equals,
Yeah, we
okay.
said when n is 2.
Yes, when n is
You
2.
substitute, don't forget we are using the formula.
Yeah,
An plus 1 equals 1 plus 1 over an.
yeah, yes.
Uh-huh.
Oh,
Do you get
yeah,
that now?
A2. Yeah. Um,
Hope you are making progress.
yes, sir. Okay, I'm there, sir.
Okay.
Yeah.
So let's now move forward from there. I'm going to add another question. The question says, from the above, deduce partial sum S7. Reduce partial sum S7. Can you do that?
Maybe S5 plus S2.
Eh. Okay.
Oh, that one will be
You
long.
can try that.
Okay.
Now, we stopped at when n is 4, right?
Yes. Okay,
To
yes,
get
that's it.
A5.
Yeah.
So we need A6 and A7 now. So we now say when
Okay.
n equals 5. So A6, don't forget, you're still using that formula, the recursive formula, A1 equals to 1, and an plus 1 equals 1 plus 1 over an.
Yeah.
So this will now be 1 plus 1 over A5. Is that Clear?
Yes, sir.
Now, what's our A5? Our A5 is 1 plus
Yeah.
3 over 5. So if you evaluate that, 1 plus
3
3
over
over 5.
5.
So that will give us what? 8
8 over
over
5.
5. So this will be 1 plus 8. 1 over 8 over 5, which you can say is 1 plus 5 over 8. That's your A6. Now, when n equals 6, so we are going to have A7 now. Equals 1 plus 1 over A6. And that is 1 plus 1 over, if you evaluate 1 plus 5 over 8, so that will give us what?
That will give us 8 plus 5
That should
is
be what?
8 plus 5 is 13 over
13.
8.
13 over 8. Okay. Okay, let me check. 13 over 8. And that will be 1 plus 8 over 13. Abi?
Yes, sir.
Okay. So S7, can we now say it's going to be A1 plus A2 plus A3, A4, A5,
Mhm.
A6,
Yes,
A7. So that's going to be 1 plus, yes, 1 plus 1.
1 plus 8, 2, 1.
Abi? Is that
1
not 1 plus
plus,
1?
I think 1, yes, 1 over 1. Yeah, 1, 2.
Mhm.
Yeah.
Is that clear?
Then, yes, it's correct.
Okay.
Then
A3,
8, 3. 1 plus 1 over 2.
I'm coming. Let me scroll up a bit since you have it.
Okay.
1 plus
Plus 1 over 2.
1 over 2
So
plus
the 1 plus 2 over 3.
2 over 3. Okay.
Plus 1 plus 3 over 5.
1 plus 3 over 5. Okay. Plus
Plus 1 plus 5 over 8.
then
Then 1 plus 8 over 13.
1 plus 8 over 13. Okay. Now we had the way we have added the whole numbers will be added
Yeah.
together. So this will be 1 plus 2 plus 1. This one plus 1
2,
plus
6,
1
7, 8.
plus 1 plus 1. Is that not it?
1, yes. 3,
Then
4, 8, yeah.
the fractions 1 over
1
2,
over 2
2 over 3,
plus 2 over 2 plus 3 over 5
3 over 5 plus
plus
5
5 over
over 8
8 plus 8
plus
over 13.
8 over 13. So this will now give us 8
Yeah.
plus 1 over 2, 2 over 3, 3 over 5, 5 over 8, then
8 over 13.
8 over 13. Now, what can you say about S5 and S7?
Mhm.
Look at the
Yeah.
first term.
The first term increases by 2,
Okay. So can I
while
okay
the
write this first because we have
okay,
limited time.
okay,
Quickly write this. We have 5 minutes left, so we'll rejoin after that. Quickly write that.
okay. From there.
Okay. So what's now the next thing? I was
So you
asking
said
you, what
the
did you notice in the
yeah,
first terms of S5 and S7?
7.
In S5
So
is 6. In
yeah,
S6, in S7 is 8.
is 8.
Now,
Then the series or sequence.
okay, 1, 2, 3, 4, 5, 6 terms
Okay.
for the S7.
Yeah,
6 terms. For the S5,
4 times.
4 terms. So can we now have a general formula for that series, for that recursive sequence
Okay.
that we can say, okay, if you substitute XYZ for N, you're going to get this value.
Okay.
For instance, now, for instance, I'm coming. Let me. So Xn, for the first term, I can say is N plus 1. Let's check it.
Okay.
If N is 5, I'm going to have 5 plus 1 to give me 6. Do you agree with that?
Yes, sir.
If
I
N
do.
is 6, I'm going to
I
have
have
7 here.
yes.
If N is 7, I'm going to have 8 here, which is the first term that we have here.
Yes.
Okay.
Yeah.
Do you get that now? Now, let's now
Yes,
look
sir.
at the fractions. So I can say plus 1/2 plus 2/3 plus 3/5 and so on until you get to the nth term, which you can say is 2n minus 5 over 2n minus 3. Now let's check it. If n is 5, if n is 5, you substitute 5 for n in n plus 1 and substitute 5 in 2n minus 5 over 2n minus 3. Is that clear?
Okay.
So let's do that and let's see what will happen.
That's 10.
We have less than 1 minute.
That's 5 over.
Write it down and evaluate it. So you know you have to be logged in if you are logged out.
Yes, sir.
Okay.
Okay, 5/7. Okay. Log out.